Welcome to a new episode of ThatITShow podcast. So last time around we stopped with Intel CPUs on 486 generation, and now we're going to go through or try to speed through Pentium generation of Intel CPUs. So Pentium 1, 2, 3, 4, Pentium D, perhaps whatnot. I have a sneaking suspicion that this episode is going to be longer than usual because there's so much to discuss. At the same time, you cannot really overstate how important these generations of CPUs, at least some of them, were for future Intel generations of CPUs as well. But yeah, let's roll the intro. This is the new episode of ThatITShow podcast, and let's start the conversation. Okay, ready for the first question? You're not. Okay.
I'm trying to emulate the speed of Pentium.
No, that's not the speed of Pentium. Come on, don't look at it from today's perspective, Mr. General, after the battle.
So, Mr. Intel fanboy, let's go.
Intel fanboy. Okay.
Yes.
Whatever. I have a marketing question for you, or maybe patent question for you. Why Pentium, not 586?
I was just waiting for that moment when you're going to go into marketing. This is the proverbial moment of the whole show. So let's start with the insanity that is patent law. And to be completely up to the point, you cannot patent a number. You can,
or so they decided.
You can trademark anything, but you cannot patent or trademark a number. So what Intel did is that after the fiasco with the different versions of 386s, 486s, and so on, they decided they're going to own the name of the processor, so that the usual suspects cannot copy the processor name and say that this processor is the same as the other ones. So basically what they came up with was the name. They needed a name that would be a word, and they decided it's going to be a Pentium, because this was the fifth generation of the processor. Internally they called it P5, because they also decided they're not going to call it 586 internally, because it is going to create another set of problems.
Do you remember what the other manufacturers of said, let's say, competitive CPUs, what some of them used for the product names?
I honestly don't.
5x86, stuff like that. Do you remember that?
I remember that 586 became a thing, and a couple of other
and
versions.
6x86 or stuff like that.
Yes, but the thing is that probably the Pentium was the first one where the other processors actually weren't that good as the original one.
Okay.
I think that the P5 or Pentium was the first architecture that actually made a whole lot of difference when compared to all the other technologies.
All the previous generations?
No, all the other technologies on the market.
Oh, okay. Cyrix, AMD,
so Cyrix, AMD, VIA, and so on. This is the point where they start lagging behind.
Yeah, okay. That's a fair point. And when you think about those generations of CPUs, and we kind of covered bits and pieces of that in some of the previous episodes, not necessarily in this series. What is your most vivid memory of the Pentium CPUs, if you remember that time? Because I have some. Do you? By the way, do you have a regular Pentium PC at home, or
probably yes?
Okay.
By probably I mean somewhere deep in the dust of the warehouse that is my attic. There is a Pentium, probably at least a chip, if not a fully functional computer. But do I maybe remember something? Yes, because the jump from 486 to Pentium was a big one, and I think I had a Pentium 75, if I remember. I may be misremembering because it was a long time ago. And I remember that it was, when I first saw it, it wasn't my computer, it was a computer of a friend of mine. It was amazingly fast. It was amazingly fast, and it was able to do things that I wouldn't expect a PC to be able to do back way then.
Okay, cool. That's good. Well, let's move it along. God knows we have a lot of things to talk about. So basically, what we are referring to here are generations from Pentium I to Pentium D. That story kind of started in 1993. That's the year when the Pentium I was introduced, and after that we had quite a few revisions of the Pentium brand, let's call it, or multiple different generations of them. Some of them better, some of them way worse. And that culminated at the end of the story with Pentium Ds, which, if you ask me, are the worst CPUs that Intel ever made, but we'll get to that as well.
Let me just quickly throw a thing about Pentium D. I don't think Pentium D was the worst processor.
I know you don't.
I think the Pentium D was the April joke of the processors. It was just,
April the 1st.
Yes,
today.
April the 1st. So it basically it was a processor that never was. And
I had one.
No. But the processor that never was, because what they wanted to do, they wanted to be creative. And for
I
some
would call
reason,
that the opposite of being creative, but
and
I
for
get
some
where you're
reason
going.
they didn't get the memo. So what happened is that they simply slapped two processors together.
That shouldn't be slapped together.
Called it a day, and that was it.
Yeah, let's have a quick beer type of product.
Yes, I think that this is a project. This looks like a project that was done in a week.
Okay, probably took a little bit longer, but yeah, the metaphor still stands.
So there is that problem when your parents are calling and you need to do something because you have only 15 minutes left before they come home.
Yeah.
And then you decide that you are going to create a double core processor.
Yeah. Okay. Let's say that's a task for at home.
Yes. So this is one of those things.
Okay. The way in which Pentium was introduced to the market in terms of technology was super interesting for me because if you look at the physical aspect of it, of what the CPU looked like, and I don't think that Intel repeated that at any time in the history afterwards. It was actually two different types of products. It was a Pentium CPU, or you had what was called the overdrive processor, if you remember that. I never saw the overdrive in action, at least in my PCs. I saw that on some other boards, in some, let's say, business, at some business clients that I used to work for, but I never saw that in production. The idea of the overdrive, for those of you who haven't had the chance to look through the pages of history, was you could stick a Pentium on top of the existing CPU, basically, that had additional pins that you can put it on and gain, let's say, Pentium compatibility from, I think it was 486 at the bottom or something like that. It was a very interesting way of doing upgrades, let's call it that way, and I'm going to stop there because I don't think it ever repeated afterwards. Every single upgrade from that point onwards was either a completely new CPU physically, or it was a different socket and a new CPU physically, depending on the generation.
Okay, but one of the reasons for the existence of the overdrive, because the overdrive existed up until Pentium III, I think.
Okay.
The reason was that Intel kept changing the pinouts for the processors constantly.
Which they do till this day,
yes,
just like AMD.
Yes, but AMD is pretty tame in the last couple of generations.
Yeah.
You can use processors that are even, I don't know, 3 to 4 years old on the previous motherboards, and they're going to be supported. But Intel, more out of necessity and less out of marketing reasons, kept changing the pinouts. And the thing is that they had to provide the overdrive chips simply because the people weren't so inclined to change the entire motherboards and everything. Mm-hmm. More or less because the motherboard was so expensive.
Mm-hmm. And it wasn't necessarily an era in which you bought the motherboard as a standalone component.
Yes, this is the one thing. And the other thing was that you didn't want to buy the motherboard and the memory because they cost more than the processor itself. And right now, motherboard and the memory are something like, if you're buying a higher end processor, motherboard memory can be a third of the cost of the memory.
No, they can also be 3 times the cost of
Okay,
the
yes,
CPU.
yes, but you now have a choice.
Yeah, much more choice.
So
correct.
now it doesn't make sense to try to upgrade the processor itself simply because of the processor, because the rest of the computer is going to be a bottleneck then.
I think that there was one other, let's say, semi-reason. 486 was hugely popular.
Yes.
And out of that came the necessity to offer some kind of upgradability, which didn't necessarily mean you have to change basically the whole system. So the 486s and their various variants were quite popular on the market. This was what marked, let's say, the real kind of let's say, fight on the market between all of the clones and whatever. There were many products available. The prices kept coming down as well. So the overall, let's say, structure of that led to a situation in which the 486 generation was hugely popular, and out of necessity, Intel decided to have the overdrive thingy as well. They started with 66 megahertz. They had a 75, you were correct there as well, and 90 for
Yeah, I think
Pentiums.
yes.
I remember one of my friends from college, so this was 1995, had the Pentium 90. I was like, wow, because it was insanely expensive to get a system that was equipped with a Pentium 90, albeit he was a software pirate, so he had a lot of money to spare, so that also was probably a part of the story. Basically, it was such a huge leap forward compared to 486s, and as you rightfully mentioned, and completely correctly, it marked a significant departure in terms of performance to other players on the market who were constantly trying to copy Intel. But there were also some additional technologies which were introduced as a part of the story of Pentium that became super important afterwards. And my most notable, let's say, additional technologies that were let's say, introduced while Pentium I was still a thing, were Pentiums with MMX, something that we're going to have a chat about today a little bit, maybe in a separate episode. It's a hugely important topic. And the second thing was the popularization of the PCI slot, PCI connectivity. Later on, when we reached Pentium II, that was expanded to include AGP, or Accelerated Graphics Port, which didn't live all that long for some reasons. But these two things, especially the PCI is still present on many of the motherboards today. And we're talking about technology that was introduced in 1993-4. It's 2024 now. So 30 years later, you still have motherboards that you can buy today on the market. Just walk into a computer store that have PCI slot, although they are now, few and far in between. In terms of, let's say, the deeper technical things, this is where Pentium was significantly different, or it was a significant departure to some of the things that Intel did in the previous generations. This is actually much more, I think, important to discuss than just purely some of the slots or something that I just did. The Pentium I introduced a lot of very important aspects for the computer architecture that we still use today.
Let me ask you a question.
Yeah.
Vedran, what is superscalarity?
Oh, yeah. So now I'm a computer architecture professor. Yeah, that's where I was actually going.
Yes, I said no.
Superscalarity or superscalar CPUs, which is all the CPUs on the market nowadays, is a form of what we call instruction level parallelism, which can significantly impact the way in which you execute instructions in the pipeline, especially for a code that can be internally parallelized on the instruction level. This is something that's miles ahead when you look at it 30 years onwards. When you look at 486 generation, over your shoulder in the direction of the history, and look at Pentium, we're like, wow, this is so important as a thing that Intel did. So it's a form of ILP, or instruction level parallelism, on a single CPU on a single processor, and over the years that got expanded to a concept that can be used on multiple cores, even on multiple sockets of now CPUs, because superscalarity is nowadays a thing that's, as I said, implemented on all of the CPUs that exist. Super important concept. If we had much more time in the episode, or maybe we could do a separate episode about these superscalar, out of order, in order execution, all of these things, because they're still present to this very day. Actually, some of these technologies are the prime suspects and the reasons why we have so many different security bugs nowadays. Especially the out of order execution has been the center of so many security issues in the past couple of years. It's just insane.
Okay, so when you mentioned bugs, let's talk about the most famous one, the
Pentium one.
the FDiv one.
Yeah.
The one that I think that this was one of the most important bugs when it comes to hardware design.
Okay.
Simply because this was one of those things when people realized that hardware and software are not so different. Or to be more precise, that you cannot simply trust that the hardware is going to be completely correct and then blindly go writing software for it. Because sometimes you're going to have bugs or problems that are going to be visible in the hardware and that you are going to have to write around. Previous processors didn't have bugs; they have undocumented features. And this is one of those jokes, but it isn't a joke. When 6502 came out, there were undocumented functions. Those undocumented instructions were basically the result of the design of the processor. When people realized that they can interject into some steps of some instructions being run. So what they were doing, hijacking part of the instruction sequence, and the CPU was doing the instruction sequence, and then you could use a set of instructions that were coded to a special opcode and use it for something. Pentium bug was different. Pentium bug was actually a bug or an error in computation that was visible when you did floating point division.
This was actually something that was discovered by some kind of a professor in Virginia University somewhere, whatever. But more to the point, these types of bugs, later on we got microcode updates and whatnot that you could use to kind of like go around these sorts of problems. And there have been many, many, many microcode updates for these sorts of errors over the years, not the topic today. But actually more to the point, a very, very important point that you just made. This was a FPO bug basically in the lookup tables. That's where it was. The reason why these sorts of bugs are even possible, and actually they're quite easy to happen in a CPU design, is because of something that you mentioned in one of the previous episodes, which is it is actually kind of difficult to make a electronic device do FPU stuff. This is one of the reasons why this is so, imprecision of that is baked into the products that we still use today. Because again, decimal places in binary code are so complicated to do.
And this is one thing. And the other thing is that you need to make a big distinction, because FDiv bug, what it created was that the precision that was expected from the floating point wasn't correct. It doesn't mean that the floating point suddenly stopped making roundups or stopped making basically errors when it comes to interpreting numbers, because there is no way for you to directly translate decimal numbers with floating points into floating points in binary. So the problem was that the floating points in binary that got translated weren't the ones that we were expecting, but it doesn't mean that the rest of the processor was capable of doing something that is impossible. So the bug was that the incorrect value wasn't incorrect in the right way. So this is one of those things that needs to be explained.
Computer science metaphors and jokes that can be done out of that are just incredible.
Because you when you are trying to translate or trying to recalculate a number from a decimal value to a floating point value in binary, you are going to make a precision error.
Yeah.
And this error was different in Pentium processors than it should be. So they were expecting something else, and this didn't happen, something else happened. And this is complicated to explain to somebody who is first introduced to binary mode, because they think, okay, the division was wrong. The division is usually always wrong.
Yeah.
But it was wrong in a wrong way, so it wasn't dependably wrong.
Yeah, you couldn't actually. I saw an article stating that these sorts of errors happen once every 27,000 years, some insane number. But what happened as a result of that is much more important. Intel publicly did admit to the error. They actually did issue a new version of the chip with the, let's say, error fixed. It cost them something in the roundabouts of $500 million to do that, which was a huge amount of money in 1993, 4, 5. When Pentium was active on the market. But what I also remember from that age, because that's the time at which both of us were already hugely, reading computer magazines and whatnot. It was quite visible that a lot of people who were on the IT market, especially from the, let's say, PR and journalistic perspective, were quite eager to knock Intel off, let's say, their so-called pedestal. Because there were quite a few articles that were completely, they missed the point. They don't understand what the bug is. Out of that came the public storm that was quite negative and whatnot. I'm not defending Intel. I just understand the technology reason behind it, and therefore I understand that the way in which that error happened was always possible. That's
yes,
it.
This is one of those things, and I think that, for example, Rawhammer or Spectre or Meltdown were much bigger problems.
Correct.
And they didn't get so much media attention. And the thing is that both the FDiv bug and the, for example, I don't know, Spectre or Meltdown were just simply solved by a software solution. You can actually go around the problem. You're going to lose some speed, performance, or whatever.
In this case, it's going to be a significant amount.
Yeah. Yes, in the Meltdown, it's going to be a significant performance loss. But in the FD bug, I think that it could have been done much easier, much simpler, in a much simpler way, because the processor was simpler. And today, this would be the way it would have been done. Nobody would say, okay, let's replace all the processors in the market.
Because that's what basically happened back then. And Intel did, if I remember correctly, they did offer a replacement CPU basically to anybody who wanted to replace it, but I don't think that millions of people were replacing their CPUs at that point.
I know that a couple of people that I knew that had this processor, they just said, okay, why? Because replacing it meant that you will have to pull the processor out of your socket and then wait for a couple of weeks or months before you get the replacement one.
Yeah, it was just a non-starter for most people.
Now let's just quickly mention another few things. Let's talk about microarchitectures, and let's talk about how and why, what we are talking about. Because basically what we are talking about today are three microarchitectures. We are talking about P5, P6, and NetBurst. Because these were the ones that were
over the time span of the products. Over the time span
of the whole thing that we are talking. Because what I want to try to get across is the difference between the microarchitecture, the name of the processor, the stepping, because the stepping is also a very important thing.
Respinning.
And the name of the architecture or the release part or the project that the processor was. So, for example, from on top of my head, Preston or Northwood or something like this.
Prescott, yeah.
No, but I mean, I said, okay, let's slip with the tongue. But the thing was that when you're designing a processor, you design an architecture. This architecture is called a microarchitecture. Then you revise it, and then you get steppings. Once you do another microarchitecture, so something that is different in a way that, I don't know, in software world, it would be a new revision, so a completely new version. So basically, let's call P5 would be an microarchitecture. It would be a major number for the release. Then you would have steppings, A, B, C, D, E, and so on and so on.
A0, whatever they were.
Yes.
Yeah.
And then for different re-releases or different changes in the architecture, you got additional names that were names of the project. Because some of them were based on, I don't know, P6, and then they were trying to push different things in the P6 architecture.
Yeah.
P5, more or
Exclusively
less,
Pentium, yeah.
P5 Pentium came in two different flavors. One was the original Pentium 5 with all its revisions, all its steppings. And then you got MMX version that was completely different from the outside, but it was the same processor with added bits.
Yeah, with additional registers to speed up some of the multimedia instructions, but this is on a very low level.
So it's important that suddenly when we are talking about processor, we are not changing everything. We are changing it bit by bit, calling it different names, and trying to establish different things. And I'm immensely looking forward for the end of this episode, because this is the time when Intel was making major mistakes.
Yeah.
The story of the Pentium 1, 2, 3, 4, and so on, 4 being 4 and then D, is the story of how Intel was suddenly on the top of the world when it came to design the processor, and then being obnoxiously hard-headed and stubborn, hard-headed, and just decided that they are going to stick to the processors that they know how to do, and they're going to just make a single core processor. This is going to be it.
Yeah, okay. We're definitely going to go back to that part of the story.
So now
Pentium Pro.
No, before that, Pentium, because you said that it stopped at 120 or 133.
Yeah.
No, it didn't. The highest...
150?
No, 200.
I remember MMX versions were also a little bit higher than Pentium 90. No, I didn't say that Pentium 90 was the last one. I just remembered using those.
Because the problem was that also what changed is I'm looking at the table, the chart on Wikipedia that is mentioning all the different versions, and the reason why I'm using Wikipedia is they don't make many mistakes, but they are much easier to read than the Intel documentation. Intel documentation is full of different things, and Wikipedia, unfortunately, is much more easier to read when you need to find some things. The thing that I was looking for was to try to establish the difference between different technologies and different die sizes. So because the P5, the microarchitecture, was basically 800 nanometers. Then after Pentium 66, it became P54C, 600 nanometers. Then it became P54CQS, 350 nanometers. Then P54CS, 350 nanometers. Then P55C, 350. This is the Pentium MMX. And this was when the MMX was introduced, because the last one...
1997, by the way.
The last Pentium without MMX was Pentium 200.
Yeah.
And also the different embedded versions. Then they stopped, and then later came P6 based Pentiums. So the last one was Pentium MMX 233, and this was the one that was done in P55C 350 nanometers.
Yeah, and it was 66 megahertz FSB.
Almost all of them had 66 megahertz FSB. The thing that changed was the amount of cache. The thing that changed was the power requirements.
Yeah.
Because Pentium started with puny 14 watts, then 8 watts. Pentium 75 was 8 watts.
Yeah, I know.
The Pentium 66 was 16. So this was the puny 8 watts dissipation, and it came all the way up to 17. And I mean puny because today the idea of having to cool 8 watt part is just simply
ludicrous.
You just slap a piece of aluminum on it and that's it.
Yeah, I call it a day.
Yeah. So this was a huge thing, but why am I just reading from a table? Because I want to get across one thing. Intel did a hell of a lot of job. They were doing a lot of tweaking and redesigning and redesigning of the chip since it came out. First version came out in 1993, and the last version on the market was in 1997.
Yeah, MMX.
MMX,
yeah.
yes, and I think that MMX was being produced late into the 2000s. I'm just going to
quite
check.
possible. Yeah.
Because this was the one, I think, was it the 486 or the Pentium that was the one that was flying on the shuttles?
I think 486. I don't think Pentium made it to the shuttles for the FDebug and other things, but I'm not exactly sure. I remember vaguely reading or hearing about that particular topic somewhere. Are we done with the Pentium?
Yes.
Okay.
And no.
Why?
Let's talk about the Celeron.
Oh, Lord.
We need to.
Yeah,
we have
I know. Yeah, I know. I would say that this is the first, the Celeron as an idea, as a concept, is probably the first time that I ever felt rage, and quite a significant amount, at a hardware company, if you can relate.
Okay.
Because the Celerons were, I mean, I understand the necessity for the product. Pentiums were expensive as shit. So the idea of having a slimmed down version of a CPU for, let's say, lower end or mid-range market or whatever for general users made sense. But apart from a couple of parts, which we'll get to, I'm sure, Celeron was and always will be one of the I don't know, pieces of S in terms of Intel's reputation in my book. But yeah, they were sold in hundreds of thousands.
But the thing was that with introduction of Pentium, Intel realized how much money they can make on a processor. And what they did is that the price of the Pentium itself was much higher than the price of the 486.
Yeah.
And since we are talking about a couple of years, AMD and Cyrix and all the rest of them came up with different versions of what was 486 with modification, but they were much cheaper.
Yeah.
And Intel had to create something that is going to be cheaper than the initial Pentium.
Yeah, they wanted to be competitive on that market as well.
Yes, and the other thing was that they didn't want to spoil the name of Pentium by creating a Pentium SX or Pentium...
Lord Pentium.
The light edition.
Yeah.
It will be probably light edition or something like this. Or
LT.
Yes, Pentium for Poor. So they decided that they're going to create a new name, and this name is going to be Celeron. But for reasons completely unknown to anybody else, they decided they're going to switch the sockets. They're going to create something that's going to be completely awfully different than everything else, and at the same time, not quick enough.
Yeah.
Because Celeron, the reason why I now wanted to talk about Celeron, because Celeron was introduced with the Pentium II. It had the same architecture, but it was much slower.
Less cache, less this, less that. Yeah, it was
and it had the slot 1.
Yeah, we're coming back to slot 1 when we start talking about Pentium 2, but before that, we have to talk about Pentium Pro.
Okay, Pentium 2 is basically Pentium Pro.
Yeah, but still, Pentium Pro was aimed at a different market.
Pentium Pro was another groundbreaking thing.
Yeah, it's the first P6 chip, basically.
Basically, it's the first chip that has that kind of has cache, a lot of it.
Out of order execution.
And a lot of things that we are seeing on today's processors.
Physical address extensions, PA, was also introduced in Pentium Pros. Dynamic execution, different pipelines. There were quite a few additions to this one, and it would also required a new socket. But the product itself was actually aimed more towards the workstation market than to the regular desktops. You could argue, in a sense, that Pentium Pro is like a precursor to Xeons, in a sense.
Yes, because
I think the metaphor works.
I think that what they did is that I'm going to speculate here. And I'm going to go with the speculation that they had the P6 architecture, but they weren't able to produce as much or as many processors as they would have liked.
Okay.
So what they did is that they created a high-end core. They created a high-end processor, and they were marketing it for the supercomputer market and the high-end workstation market, simply to avoid the problem with the delivery. They didn't have enough parts to be delivered, so they decided, okay, we are going to create
Until we improve the process,
Until we
let's
do the
just
process-
make money.
let's just make money, and let's show the people that we have the next processor. This processor is extremely fast, but the scarcity is going to make it much more expensive.
Here's the kicker for you. I don't know about you, but I did have a Pentium Pro.
I didn't.
Yeah, it was quite a bit faster than the regular Pentium. This actually, when you look at the timeline of these processors, and when you start comparing that to our stages in life where we were, in college and whatnot, starting our side hustles, you started working for a computer magazine just like I did and whatnot. We actually got access to a little bit of money on the side as a result of that. My primary source of money lacking was buying stuff. And I also had some friends in a couple of companies that used to work with some of my other friends who were constantly adding some stuff on my table. And one of those was a Pentium Pro. And I noticed that it was a significant departure in terms of performance when compared to the regular Pentiums generation 1. But I mean, what Pentium Pro did with all of the new technologies that were built in, they're the basic of almost all of the CPUs that we still have on the market. Much better floating pointing performance. They had separate execution units, wider data path, a lot of additional extensions, a lot of additional registers, whatnot. It was quite an upgrade in a span of just, let's say, 2-3 years. I think it was something like that, 1996, 1997. Which I think the Intel should be commended for that. They were just steamrolling ahead like crazy. And that makes your speculation of 2 minutes ago seem quite plausible also as well. It makes sense, all of the things that you said.
What the P6 did is that you could say in order to avoid the FD problem, but also in order to incorporate something new, they incorporated micro instructions or micro operations. And this was the thing where you can actually translate individual instructions into operations that are not hard-coded in hardware, but are instead designed in a lookup table. So you create a lookup table of all the instructions, and then you can change what your processor can do. And what is amazing for me is that it's basically a RISC.
Yeah,
Microprocessor is basically a RISC processor.
Every single CPU that Intel has since then has been, and at least internally, basically a RISC CPU. But that's we are going to talk about the CISC and the RISC architectures in a completely separate episode. But fair point, I'm completely with you. Micro operations that were introduced there are heavily reminiscent of the way in which RISC works.
The thing is that that I want also to mention, and the reason is why I was talking about the fabrication and the low availability of the processor, was that they called it the multi-chip module. Multi-chip module meant that you actually had the cache and you had the microprocessor side by side. They weren't incorporated in one die. The problem or the solution why they did this was simply the cost.
Yeah, technology.
They had a problem how to create such a complex technology on one die. And since it's much easier to make mistakes if you are doing two separate processors, so you can pick and choose which one is working, which one is not, and not having to throw away the processor because the cache is not working, vice versa. They created separate dies. So this was the first processor with a lot of cache, but the cache itself wasn't on the processor,
which is going to happen in the future. And
I think this was where they got the courage to create the Pentium D.
I get what you're going with this, but let's get back to this one. So, Pentium II. is the next one. I think that there are a couple of topics that we need to cover when talking about Pentium II. The first and foremost is the change of the socket to a slot design. Definitely something that we need to cover. As a part of that, I'm very eager to talk about Celeron.
Okay.
Because that, in that topic, the appearance of Celeron for some things makes sense. And then in terms of the actual products, we're talking about there were a couple of generations of these Pentium IIs as well. The Shoot, Klamat, whatnot. I had all of them. I started changing CPUs like some people change underwear. Not that I'm very proud of that, but it is what it is. I started going through hardware very quickly. I'm sure that you had some similar experiences, maybe not with that generation, but whatever. So in Pentium II, with MMX now basically being a standard, they switched to a slot-based design. The first one was slot 1. There were a couple of slots afterwards, and AMD had some slot-based CPUs as well in that generation, but not the topic of our discussion today. They had they called it some kind of a single-edge contact, whatever, packaging, whatever. The idea was to kind of make the CPU a little bit more compact. They had, the Pentium IIs had much better branch prediction, the instruction decoding, different, larger and faster layer to cache and whatnot. So this was, again, a big upgrade when compared to Pentium Is in terms of the speed and everything related to that. And then also, more to your point from, let's say, 10, 15 minutes ago, they also had a couple of different, I would call them, let's say, different products or generations of Pentium II. So they had the Klamat, which was introduced in 1997, then Mendocino, which was the Celeron we're going to talk about, and the Shoot version, which was introduced in 1998. Let's start with the Celeron for at least a second. This was the seminal moment in IT history, if you ask me, where you could actually get something of, let's say, a very advanced architecture on a low-level product, or in terms of the money. Celeron was always aimed at the lower level of the market, or low cost. Market slot 1 marked a significant departure in terms of what you could do, albeit in less than supported ways. You needed to do a little bit of soldering on the slot 1 Celeron CPU, and what you could do is up the performance of the Celeron, for example, 300, which was a 66 megahertz FSB Celeron, to 100 megahertz version of it on the FSB, which also, because of the locked multipliers, meant that you raised the clock from 300 to 450 megahertz. And those among us who were playing a lot with the hardware and buying and spending all of their pocket money and everything from side hustles on hardware actually had a dual socket version of that as well. I had one. I think I still have it somewhere. Just like you have the attic, I have the basement. It's the same idea. And I was very terrified to do the soldering, although it required, I think, just one wire was needed for the two contacts. But that one worked for me very nicely. That introduced me to a couple of concepts. One of them was what it means to have a multi-socket motherboard, multi-core architecture, basically, because there were two CPUs there. And at the same time, I started playing more and more with Linux and some of the stuff that were happening around the same time. Although I started with Linux a little bit earlier, but this was one of the machines on which I probably spent the most time compiling kernel because it was fun.
And the necessity. But then again, but I'm going to check there and say that the slot 1 had, there was a reason behind the sanity. The idea was that what they did when they created Pentium II was that they decoupled the Pentium Pro into two chips. And they were trying to get the core to work and then have the separate cache that's going to be either on a second chip or a separate chips on the slot.
Actual physical CPU
on the slot. So what they created the smaller motherboard or daughter board that was able to hold all of those. And the idea behind this was that what they were able to do, they were able to create something that would be cheaper than Pentium Pro, because it was cheaper to produce. But they also lost some of the advantages of having the cache die by die on the single sort of on the single die, basically. They solved that problem with the last Pentium II. The last Pentium II was the one. The one that was called Dixon.
Oh yeah, correct. Yeah,
the one that actually had on one die had the cache and the processor.
You saw exactly 0 Dixon processors on the Croatian market. They were non-starters.
I think that this is one of those things when Intel also started the. We have this amazingly fast part, but it wasn't a paper launch. Dixon existed, but they said, okay, we have this amazing part, but we are going to launch it, and everybody's going to get it, and then asterisk saying everybody is going to be some selected partners that are going to be making laptops out of them.
Yeah, I was pretty lucky with the, let's say, the pocket money and side hustles back then. So I was able to go through all of these. So I had the Clamat, the Celeron, and the Shoot. Went through 4 or 5 different computers at that particular point in time. And as they were introducing newer versions, new technologies came in, like larger L2 cache integration of that. The products were compatible with slot 1 motherboards, which played a significant role in terms of how you could upgrade, which was very user-friendly. But I think that generally speaking, if you were to look at the Pentiums I to IV, and if you were to pick and select some of the most prominent CPUs that existed in that time period, I think the most important CPUs are yet to come. For me, Pentium 1 and 1 was important. Pentium 2 was importanter, if you want to use that stupid word. But where most of the things that I learned about CPUs and how to incorporate them, and when I did a lot of hardware compatibility tests and started writing articles and testing and whatnot, that's actually Pentium 3. And for me, Pentium 3 is vastly more important than any of the Pentium 4s for reasons that we're going to discuss very soon.